Hi dear students, today is our lecture 4 and we will be talking about statistics and basics of probability. So statistics, we can define statistics as the discipline which provides methods for organizing and summarizing data, and then we are basically drawing conclusions on the basis of that information. Statistic concepts and methods are not only useful but indeed often used around the world, and we are basically using the concept of statistics in our day-to-day life. And whenever we are talking about decision making, the discipline of statistics is teaching us how to make intelligent judgments and informed decisions in the presence of uncertainty and variation. And we already know that if there is no variation and there is no uncertainty, then there will be a very little need of statistical methods. But in our real life problem, we have uncertainty and we have variations. So that is why it is extremely essential to learn the basic concepts of statistics. So, for example, if every component of a particular type had exactly the same life, so such as if you are buying batteries for UPS and the life for every battery is the same, right? So then just one single observation would be enough to um, provide the desired information. But in real life, the battery life is not the same. So that's why we need to learn concept of statistics. Here we can divide statistics into descriptive statistics and inferential statistics. So descriptive statistics is basically allowing the researcher to get an accurate first impression of data. We can estimate the mean, median, mode for our data, and also a histogram. That's very useful in descriptive statistics. However, in inferential statistics, what we are saying that okay, we have a sample and we are saying okay, because a sample was drawn from a population, so this sample will have the same characteristics as the population, right? And because it's very easy to analyze a sample rather than whole complete population, so we are inferring that, or we are making decisions on the basis of that um, sample, and our assumption is that because the sample was drawn from that population, so the sample will have the same characteristics as that of population. And we cannot analyze the whole population because data collection, it takes a lot of time, it requires a lot of money, and sometimes tests are destructive tests, so we cannot like sample our whole population. Other reasons could be maybe resources are not available, material is not available, stuff like this. So that's why it is a very good idea to take samples. Let's talk about types of data. So discrete data, um, data values can only be either finite or countably infinite. So if you are a quality engineer and you are interested in how many products will fail or how many products will be defective. So such type of data is basically a discrete data. Other than that, how often are machine repairs, or let's say how many students are absent in a class, or how many people are absent each day. So such type of data is considered as discrete data. Second one is continuous data. So data values are always uncountably infinite. Example would be number of points on a line. So there are infinite points on a line, right? Number of points on a football, definitely infinite, because it depends on the dimension of points. And some people are saying that okay, point is a dimensionless quantity, right? How long did it take to complete the task? What is the weight of the product? Length, volume, time, because we can divide length into much finer and finer scale, volume into much finer time. So let's say year, then we are saying okay, month, weeks, days, and then we can talk about hours, right? Minutes, seconds, and then we keep on dividing time into further finer units. So that's why we are saying okay, this is a continuous data. So let's talk about types of data on the basis of variables, right? So univariate data set could be like a data set which consists of observation on a single variable. So let's say if you are a doctor and you are considering only weight of a patient in your analysis, so it's only one variable, right? Weight is that variable. So okay, you can say that this is my univariate data set for let's say 100 patients or 500 patients. Okay, second one could be bivariate. So here um, we have bivariate data when observations are made on each of two variables. So let's say I'm saying weight as well as height of that patient. So that is basically my bivariate. Um, Another example could be weight and maybe uh, blood pressure. That's also my bivariate data example. Okay, multivariate data arise when observations are made on more than one variable. So, for example, blood pressure, cholesterol level, weight of